Thank you. So, anyone that's been coming along to GSE for the last few years will realise that I'm not exactly a familiar face when you come to testing and kicks. But don't worry, I have brought him along. So, just to quickly introduce myself, because I'm a bit more newer on the scenes, I'm James Davies. I've been in the kicks test and infrastructure team for the last about 14 months. That's about it. So, why am I here today? Starts off a little bit with this quote. So, what Sandeep said here is 80% of enterprise testing is currently being done manually. And this is a bit crazy. That's a really big number. And especially from someone of my generation, I'm coming into this industry, and we're constantly talking about the fact that we're trying to modernize everything, and we've got our agile methodologies. So we see this number, like, why is it so large? Like, what's going on here? And one of the reasons that we think this is so large is because the difficulty that comes with like testing big enterprise software. So if we have this problem, what's the solution? So one of the things that we can do to try and counteract these kind of things is, as everyone has been saying for the last couple of days at this conference, is DevOps pipelines. It's a real hot topic. And why is this? We want small, continuous cycles going over and over again because we need to be developing and pushing code really quickly. And I keep hearing a term, and I love saying it in mainframe rooms because everyone seems to cringe a little bit when you say fail fast, just because you've got the word fail in there, and it's just like, oh, that's not good. Like, we don't ever want to be doing any sort of failure. But I'm actually a firm believer of failure is a good thing in the right place. So a little bit of a story from when I was a UP. I was working in an actual team with Robbie in CNDP, and we kept having an outage. There was a bit of a problem with the power to our machine room, and we kept losing all our VMs. Day one when this happened, it was absolute horns blaring, red lights. What are we going to do? This is quite a big problem. Do you remember this? Yeah. So I was really fresh as an intern at this point and being like, oh, what can I do? So what they did is they set myself and like the other interns with some quite repetitive tasks. They were like, can you go onto these VMs and go make sure this is running, or this is gone, or this test is cleaned up properly, and so on. And it took us about 3 days to fix it. It was a really big outage, wasn't it? And the great thing was, about 4 hours later, it happened again. But this time, we'd all been just through that process, and we were like, okay, we know what we're doing now, we'll crack on. And then about 2 days later, it happened again. But every time we did it, we got so much quicker at it. And actually, as a group of interns, we even automated one of the bits we were doing, which was repetitive, on every machine. So we went from having a 3-day outage to being able to fix it in about 6 hours. And luckily, thankfully, someone fixed the power, and all was hunky-dory once again. So I don't think fail fast is something we should be scared of. I think it's good to have lots of little errors that you know how to fix rather than the error that you've never seen before. So going back to kind of like the pipeline now, this also helps with like the agile methodologies, doesn't it? If we can have these continuous cycles, we can be developing code in a very agile way, because the bits we're intrigued about is testing. But why is testing so important? So this is from a GitLab report from, I think, 2018. It's not from the 2019 one, but I found the 2019 one a little too late. So these are the 2018 stats, unfortunately. But it said over half the people highlighted their testing phase as the #1 point for like encountering delays. So this isn't just an area where we're encountering delays. This is what they're saying is the #1 phase. And testing is such like key. We've got some other good quotes across the bottom there, and it's the fact that it's key for continuous integration, that you can't really have this CD and CI pipeline if you're not looking at the testing phase. If you're having to hand off your testing phase to a manual team as part of an automated process, it's very easy to slip into waterfall again. Because if I said to a tester, like, how long is it going to take you to test this change set? And he might come back and say, like, I don't know, 4 to 6 weeks. Okay. What about Barry's change set? He's delivering in a couple of days, and so how long is it going to take to test the 2? Well, 4 to 6 weeks. All right then, so why don't we just collect a few change sets up and then you can test them all together and bam, you're straight back into waterfall. So we need this continuous integration to make sure that we can have fast testing processes so we can be continuously delivering change sets. I like the bottom stat there because that 87% is from developers. They said 87% said as soon as they have this constant cycle, it alleviates this like blocker in the process. 93% of managers said it did. So take what you want from the two, who you believe more, but good stats all around. So any eagle-eyed people would have noticed I actually highlighted the build phase. So why, when we're talking about testing, have I highlighted the build phase? And this is because where we can get unit testing. So this is our first line of defense and our first point where we can start looking, is there a problem with the code? So this is obviously, compiler's another one, but that's hopefully a bit obvious at the build stage. We hope our code is going to compile. But at the unit testing stage, we can make sure that the code that we're pushing out is at least doing exactly what we expect it to. And we can test it without having to deploy out to a system. Because if I deploy out to a system and then my code falls over, you always have that little argument internally yourself. Is that my code or did something go wrong in the environment? Who's to blame here? So if we can get those kind of bugs out of the code before we've actually deployed, then we can save a lot of time. It's almost cheap testing in a style. We also have the advantage of the fact that we have other tools in this area, like Sonar Cube. Who's used Sonar Cube in the room? It's a great tool, isn't it? You can really spot like bugs and security. Yeah, it's a really, really nice tool for highlighting really early any issues. But we always have this niggling conversation that unit testing is quite hard on Z, and it falls into the fact that the applications and these enterprise scale products are really large and complex, and it can be really difficult to highlight what is the unit that I'm trying to test here. So we've got that problem. We've also got the problem that COBOL and PL1, they're procedural based languages. So unlike like Java, which is like OOP, where we have things like Cucumber or JUnit testing, there's not the same level of support and frameworks available for COBOL and PL1. We also have the issue with knowledge, which is always the problem, isn't it? How do you share to everyone what's going on? So this isn't necessarily your developers don't have the skill to test it, but they might not know how to test it because they've never had to do unit testing in the past. So this is where we hope OpenZ unit test is going to plug some of these holes, because it, in automation, allows you to mock and fully stub out some major kicks exec calls. And we can do this by a record and playback feature, which so we can see exactly what's going on. And the best bit is it's written in COBOL and PL1, so the people who are developing in COBOL and PL1 understand what's going on. And we can have this stored in any SCM that we want, whether it's Git, Endeavor, or RTC, because then we can just plug it straight into our pipeline. And we can start filling in the first steps of getting that continuous integration cycle. So we all know unit testing isn't enough. Not always the case. I found when I was working with a few other graduates, because they were like, I've got 100% code coverage. My code is infallible. Like, there's no bugs in there. All the scans have come back, and it's all good. This is what happens when you're in a unit test. So, because I was having a bit too much fun, I did find a couple of examples here. Yeah, both bits working perfectly, just not quite together. And this is another sticking point. Integration testing on Z is not trivial again, because a lot of tools that we look at don't have this deep Z integration knowledge. So if we want to test something like a web endpoint, we can quite easily do that with a tool like Postman. We can hit a REST endpoint, and we can get a response. Yay, it's all working, right? But how do we validate that response? Is that data that it's actually given me the correct piece of data? So I would normally have to then go log on to my region, get up the application, and go and find, is this the right piece of data manually? And we've got a couple other scenarios there. So what happens if we want to simulate data changes during a test, or drive error behavior? Us in Kix, being a premium mixed language application server and integrating with loads of services, had this problem. So we have a few statements that we devised while trying to plan what we're going to do here. So we said, to meet market needs, Kix must continuously deliver new capability. And as I say, it's quite popular. To continuously deliver, we must be agile. Again, all sounds pretty good at this point. So maximizing agility, we want frequent feedback. But how do we get frequent feedback? We need high quality builds. We need to be allowing these builds to come out of a pipeline somehow. And we don't want lots of interaction from people stepping in at this manual steps. So the yellow writing there at the start and end of there really summarize it. To meet market needs, we needed good, reliable, automated tests. So what was stopping us? Right, off you pop, go and sort that out then. And it started off because we had a lot of homegrown tooling, which was not designed to be scalable. There was be lots of long-running tests and not too many of them. It's not exactly the most scalable architecture here. It's very difficult to extend. It's hard to push into a CI pipeline because it was never designed to. And as I say, it was homegrown for a very specific purpose. The unreliable tests as well, that comes back into it. Someone has to be maintaining this test material, which can get quite long, or there can be a lot going on in there. So it's just a lot of manpower to try and support this kind of system. So we set out with a shopping list. We said, right, we need something new. What do we want? We need to integrate with lots of technologies. That's pretty much a given. So whether this is terminal interaction from your 3270 panels, submitting batch jobs, or even web services, we just need to integrate with lots of different technologies. And we need it to be running with deep integration knowledge with Z. Like, that's what we're testing here in Kix and back in Hursley. We did have the added level of difficulty, though, that we are testing 5 service releases at the same time. So we don't want some tests running on some versions while we do on others. So it's just like, it's an additional problem that we're facing. So after much shopping around and much research, we did come to the conclusion that there isn't one tool out there that's good. That it's not going to fit market needs, so what we needed from it. So in this, though, we did find a lot of things that were really good. Like, it's not to say every testing tool out there is not like good or what we needed. It just wasn't quite enough in some places. So we looked at things like JUnit. It's a really common, well-known, understood framework. It's nice and simple and extensible, and it's in Java. We, on Kix, support Java. There's a lot of Java developers in the world. It's a nice language to use. And because we're doing that, we can take advantage of things like Maven to package our test bundles and have our test material in something like Java. Because we also see things like Docker provides really nice isolation and for a test environment, because we might want to have multiple test environments running at the same time. And again, OSMF, there we go, is a good way to integrate with Z. We just had to go along looking at what's available and kind of just fill in the blanks. So we did. We developed a tool back in Hursley that we now call EJAT. It allows us to test Kix at an enterprise scale. And we needed this requirement of being capable of doing 600 hours of testing every day. And this isn't just like 600 man hours of how quickly I can do it. This is a fast 600 hours. That's 25 days every day. We're running over 5,000 test classes in that time. Like, this is a lot of different test classes running with lots of different tests in it. So it's a broad range of what's going on. We have the system scaled over 10 LPARs, so it can access and pull resources from 10 different LPARs, some of which we've put out to have those provisioning environments, so it can go away and create and provision the exact testing environment that it needs for that test. Other LPARs we have as very standard existing environments because we want to know exactly how it's going to respond in a particular environment. And EJAT's been really, really successful, and we now have around the world development, service, and test of those 5 releases of Kix in support. So this is quite a cool graph, and I think it has a bit of a story to it, because we do hear a lot of concerns when talk about big changes to test frameworks. It can be a lot of work. There can be a lot of concerns about when am I going to have time, or how am I going to get this past financing. It's not a fast process. I'm not expecting to flick a switch and be like, bam, we're done, automated testing, check. So this is actually our usage of JAT over the last 5 years. And as you can see, if I pop some numbers on there, it wasn't an instantaneous process. In our first month, we did about 2,500 test classes runs. Well, last month, we ran 70,000 test classes. I'd say these numbers are huge in comparison. And this is over 5 years, so it wasn't an overnight process. Rome was not built in a day, in fact. There are some interesting points on this graph. Would anyone like to hazard a guess what they are? Christmas. They're actually the Kix GA dates, which, when you think about it, makes a lot of sense. Because up until when we were approaching the end, towards a GA date, we have a lot of developers submitting a lot of code. And this is kicking off that automated pipeline and running automated tests across those change sets. So we're obviously going to have a lot more tests flowing through our system at those times. So this goes back to the fact that we wanted something scalable, because as you can see here, we're not having a constant workload at all times of the year. But what is nice to see is, even though, as I say, GA was going out the door, we're still at one point there running 30,000 odd tests after it's GA. We're still completely running pipeline after pipeline, testing new code, even in the quiet periods. So,
James, can I ask a question?
You can.
As a customer on the other end of the testing experience, I guess, we're sort of proving stuff in the real world. When you create your test cases, I know you're saying you're running a lot here, but do you have any criteria for actually creating them? If there's feedback from the outside world, you can create new test cases to reflect anything that's happened, or are we testing the same applications and then maybe just once in a while thinking, oh, we've got no JS now, we'll do something about JS, or we've got Java now, we'll do something for Java.
Well, so
Is it quite dynamic, or is it like a big project?
it's a constantly growing system. So the tests that we write one day aren't disappearing the next. So the longer, as you say, as more features are applied, or as we go into Node.js and tests are written for them, these tests are then still around. We're running them as a regression suite instead.
Yeah. But you're running more, but is it different, or is it just you're doing the same thing faster and faster cycles? You get what I mean?
You're running the same test over and over again. Are you adding constantly to the test suite so that they're completely different?
So as we develop new bits of code, new features of Kix, we're constantly adding new tests. But what we're also doing is going through the set of regression tests that we've got and enhancing them. So not all of the tests that we have run inside of JAT. We've got some very old test suites that are still running in our old framework, but we're moving them across. But as we move them across, we apply due diligence to them. So we change the application, we make them faster, we adapt new standards to them. So we're constantly adding things to them. But we've also got our service teams. When they fix APARs and they fix problems, they write tests. And those tests go back into the main test.
That's really cool.
So that's why the chart goes back up and right after GA.
Remember, this isn't just testing on the current release of the software. This is testing of all the releases that we've got. So this has got all the back releases that service are running tests against before they ship the PTF. It's developers wanting to run some tests before they deliver their code. It's not just let's test the final build.
But these are scheduled tests. They're not just running all the time for the sake of running.
Well, every test was kicked off for a reason. We're not just sat heating up the planet because we like to. Every test is being kicked off. Either a developer has kicked it off because they want to run some tests, or our CI pipelines kick them off to validate a set of change sets, or still running tests.
So when you're doing this stuff, who's got the responsibility of managing this? Because, for example, developer comes up, he's got a new feature, he's got to do, he's got to do a test. So who's responsible for putting that into, if you like, into the test deck that you're creating, and who's responsible for managing that going forward in terms of its lifecycle?
Yeah, absolutely. Who does that? That's great. So, sorry, James.
All right.
So, we run each of our hill teams run as a cross-discipline group of people. So you've got developers, you've got testers, you've got service personnel, you've got ID folk in there, all working together. And actually, the job of testing is shared amongst them all. So you may get the developer writing a few golden path tests first, just to validate their code to do what they really need to do.
Yeah.
And then the tester will come along and they'll write a test plan and they'll augment that set of tests with a whole set of tests that the developer can think of. So we can testing things like boundary, error checking, load, stress, all those types of combinations. Once that test is written, we extract from the test material who owns the test, who wrote the test, which area does it test, all that kind of meta information, and we pull that out into the test dictionary. So then when we come to see a test that maybe 5 years down the line fails, we actually know who we need to go back to find out who should be fixing it.
Right.
Does that answer the question?
It does.
Cool. Thank you, Will. And thank you for giving quite a lot of context about JAT and how we use that back at Hursley. Because we've had quite a few discussions where we've shown off our lovely DevOps pipeline. And then people have always pointed to the test automation section and been like, right, can we have that then? And we've just been like, well, no, not really. It's an internal tool and it uses other internal tools, so it's not something we can exactly distribute. But this is where it's changed, because I get to introduce you to Galata, which is going to be our implementation of EJAT that we are open sourcing and making freely available for everyone to use if they want to. But we do hit the question, why is it called Galata? Some people don't really think it really rolls off the tongue, but it's because it's a type of moth. That clears it up, right? Ah, you're welcome. And it's that moth. So Grace Hopper extracted the body of a moth out of a relay and quoted it as the first actual case of a bug being found. So it's in dedication to this lovely moth here. So, what is Galata all about? And I think it's really built upon these kind of like 3 main pillars of flexibility. We want it to be able to integrate with anything. So we've come up with an idea that we call managers, and this is something that can plug into the Galata framework and allow you to implement a specific technology or operating system, or it doesn't really matter. We also want it to be scalable. As we said, we saw that graph. In times of peak times, we want to be running lots of tests. So we had to come up with some sort of architecture that is going to allow us to scale it up when we need it. I feel like you've got a question, Rob. No? The last one there is immutability, and I think this one's really important, because if we're passing a load of resources, a few LPARs to an automated system, we don't want to come back to that system in a complete mess. Like, we don't want it to be absolutely ruined and be like, oh, what has happened here? Like, just flames in the corner. So Galata has a full understanding that if it's going to take a resource, if it's going to provision something like a Kix, it knows how to clean up too. And this goes for every single resource that it will take. So what does it offer? Big one, deep ZOS integration. The managers that are providing Galata with this integration are written by people in Hursley that use it every day. So it's not just a fix or a workaround method to activate everything you want to be using. It is very well understood technology that is baked into Galata. It has lovely REST endpoints, so we can call it from any pipeline. So it helps in the automation side of things and pushing it into these DevOps pipelines. And it can, as I said on the previous slide, with the extensibility of these managers, we can integrate with any test tooling. So if you're currently using something, let's say JMeter, we can have a manager that will allow you to integrate with that as part of the Galata framework. So right off the block, we're going to have a integration interface built into Eclipse. So we can execute, debug, and view test output in the Eclipse IDE. And this is both tests that were locally run from a developer and tests that run in automation. So if you actually want to find out a little bit more in a bit more detail, we do have a live website as of a few weeks ago under the galata.dev. So there is a lot of information on there, all high-level stuff at the minute, but it's been constantly updated at the minute. So keep an eye on that space. We also have...
Sorry, I've got a question.
Oh, well
Does
then.
it detail the skills that whatever team of users will need to be able to use it?
I believe that is to come, because it's a very high-level architect's view of Galata currently alive. But that documentation is in development right now, and we're pushing to it regularly. Cool. We also have a couple of other places. We have a Spectrum channel for those who have heard of it and are using it, so you can come and chat to us and talk to us there. If not, and say you can always email us. So now we've talked a bit like high level. How does it actually look from like a architecture point from within Galata? So we have these things called test runners, and these are the things that are isolated and we're going to be running and to run a test. The test runner has access to all these managers. It's built upon it. As the Docker image that the test runner or wherever the test runner is running, it can pull upon this code that is the extensions to Galata. On top of that, we have the actual, what we're calling the framework, and this is the tests interactive point of view. So we use the framework to interact with the services that Galata provides, whether this is the resources or the credentials that are required for the tests, so you don't have to bake them into your test code anymore. And it's also what activates the correct managers for the test that you are doing. So neatly on top, we have our lovely little test class. So we keep discussing these managers, and we have like a small grouping of these managers. And it can kind of go into three kind of main areas. We can have the OS managers, so the ones I put on here are all the ZOS related ones. So we have our batch manager, our file manager. But we also have middleware managers. So this is what talks to Kix and DB2 and things like that. And our final one is open source managers. So this is the other tools that we might want to integrate with. And the great thing about these managers is they can be constantly be built upon. More of these managers can be written and just plug straight into the framework. So let's say we have a test class, which in that test we are talking to the Kix manager, the security manager, and a JMeter manager. The framework will go away and it will activate these managers so they are running in the test environment that is provisioned for it at test time. But under the covers, there's actually a bit more going on than that, because our Kix manager might actually have dependencies on the ZOS batch manager and the command manager to perform all the methods that it wants to offer. So not only does the framework actually control what managers are active from the test class, it controls all the dependencies that are required for it as well. And this is kind of like almost the point with managers, is they're meant to build upon each other. You don't really want to be reinventing the wheel just because I want to do a different style of manager. I should be able to access any existing technology from the other places. We do have a fourth type of manager, which we call is an application manager. And this is a very personalized and what would be written by the end user to bind to their application that they're testing. So at a tester's perspective, he can have this manager which he interacts with, which fully understands their application. So let's have a look at a very quick example of code. I promise not to jump too deep into code. But this is an example test. So we've got a fictitious application here, which we've called Galata Bank. And I thought I'd switch these off. Does one click to that? This is the first annotation which is activating our application manager. So what this is actually saying here is I want you to load that iGalata Bank object with an interpretation that my tester can interact with, which will drive my application. But not only that, I've said, right, I want you to go and have a look at the releases that you know about and pull me and say that this test can run on any release from in production to in development. We can also tag a test with where do we kind of want it to run, and like what area is it concerning. So because we're doing an account style test here, we've said right here that the testing area is account. So let's say a developer does something in the account area. When the BVTs are run across his build, it could pick up this test and run it to make sure he hasn't changed anything in this area. Our next annotation here is still concerning this application manager, but rather than an object that we can use to drive our application now, this is concerning the data that the application might be using. So in this case, we're obviously looking at an account for our Galata bank. And we've actually asked the framework here is, can you go and provision us an account? So as we're saying, when we scale and when we have these isolation of our tests running, we don't want to be clashing with each other. So if we had a hard-coded value in our test here, and I ran the test 50 times, they're obviously going to start interacting with each other because it's using the same account number. But what this annotation is doing is it's late binding to the test and provisioning me an account number that doesn't exist somewhere else. However, we can have it the other way around. We could say, right, I've got an existing data lake of accounts that I can use. Can you go select from there? And in the process, lock that account so no other tests can pick up that account and interfere with what's going on. We have two sets of annotations left now. So those first two are all to do with the application, are very application specific, while these remaining two are part of what we call the core Galata managers. So we have a HTTP manager, and this is obviously going to allow us to do HTTP calls within the test, which for any Java developers, we know this is not unknown how to do this. This is not like interacting with 3270 panels like the above annotations might be doing. But from a tester's perspective, they might want it to be consistent, because if you're not used to programming in Java, especially if you're testing like a COBOL program, you want a consistent style of testing it throughout the test. So we also have an artifact manager, and this relates now to how we package our test. So if you remember back, I said we could use Maven and OSGI to bundle up our test material so we can package it there. And what the artifact manager allows us to do is pull resources from within that bundle. So for example, if my test is doing a web service call, I could have a skeleton web service within the bundle, just in a resources folder. And using the artifact manager, I can pull out this web request, and then the tester can use it within the test. It will have parameters missing because we don't want to hard code the account numbers into there. So again, we will be using this framework to pull out the account number at runtime. So before I finish up,
Quick question.
oh, wrong way.
Coming from the mainframe loader, where we deal with COBOL, and that's what we use, and we want to build some testing, right? So you're building that effectively, looks a bit like a Ruby script.
It looks like what, sorry?
Like a Ruby script. I'm using those sorts of things. This Java. How much of that is automatically generated? How much of that is
So all this written here is physically written because it is describing the environment that I want.
right? Have you not got any REST APIs to do that?
Not currently.
I'm telling you now, you look at that, and some people like me are going to go, no, because they don't want to do that.
No. So you don't need to have all those annotations. But what you're doing through a lot of these annotations is adding meta information into the test class. So it's not
But that's not the point. The point is I don't want to do that. I want something that will do it for me.
But how you still need to inform that thing that's going to do it.
You do, and you can, if you've got something like REST API, a really neat REST API that generates something like that, all you need to say, well, fill in this, fill that, fill this in.
Or another example would be run some manual tests and record and build these objects. Right? I mean, if I'm able to test manually, then theoretically you
building it in an automated way. That's not automation.
No, we're not claiming that that is. However, yes, you're right. If all I'm doing is interacting with some 3270 and I'm doing a bit of screen scraping, I'm entering data and retrieving data, I can record that and I can play it back. Okay? That's fine. But what if I want to record some stuff and then I need to run a batch job to simulate a data change?
Yeah.
And then I need to get that batch job back and parse the output
Yeah.
and use the output of that, then work out what I'm going to type in the next test.
Yeah.
That then gets a little bit harder to visualize. And we've played with some visualization technologies to do this record and playback type stuff. And for simple cases, it's fine. But if you really want to do, start doing things like testing error scenarios, race conditions, then actually trying to record that in a way that you can then play it back gets quite flaky. And it's hard to make that stuff very robust. Now, what we've done instead is we've tried to come up with a middle ground. In that, yes, the test case is manually written, but the point of the managers is to really help with that limit of boilerplate code.
Right.
Okay?
Yeah.
So instead of, for example, saying, I want to go to Whitehead where we're provisioning with an account.
Yeah.
I'm not asking the tester to, in every single test case that they write that is going to use some data, work, contain the logic to go out into my account and get the right number and find an account that fits a certain set of rules,
Yeah.
and then return it.
Yeah.
I'm getting the test written once, and then I'm using the annotation to validate what this tester wants to do.
Okay.
So it means that the complex code I'm writing once, and I'm sharing with the rest of my test team.
Right. And then those are effectively the annotation elements.
Correct.
Okay.
Someone still has to write, which means someone has to be responsible for writing this in the test cases. Which means the job has to be dedicated to coordinated testing.
Yes.
No, that's
Because
fine.
actually testing was really important part.
Oh,
Absolutely. We're certainly not disagreeing with that. We just want to understand what you're giving us and what we would have to do to implement.
yeah, because the amount of work that we're talking about, the people who are responsible for doing those pieces.
Yeah.
So
Can I do a quick use case?
Yeah.
Where we showed a very early version of this to a customer.
Yeah.
Can
Now,
I just ask you at the time?
I tell you, we'll take it offline.
Absolutely.
All right, we'll
Yeah,
take it
thanks,
offline.
guys.
We'll do that later.
Okay. Right, coming back to that later then. So next question is, how do I actually go about running a testing class? Because it's all one thing looking at the code, but how does this actually end up operating? So there's kind of two pipelines piping into one here, and the top one is the building of the test material. So we've just seen the code, we're going to have something like that, and we'll have a Jenkins pipeline that's just going to do a Maven build and store the output in a Maven repository. So we can then either request a test to be run, so we can know the test that we want to run from Eclipse as a user, or this could be kicked off from some sort of other pipeline somewhere else via Jenkins. A request is made, and what will happen is we go and spin up a Docker container that has a running architecture of Galata inside of it. It will then go and pull that test material from that repo that we just built to. Looking at then and reading the annotations at the top of those test classes, we can then move on to the step here where we know exactly what we need to go away and provision and collect for resources. Then we get to the happy stage of actually executing our tests, and we're going through, we're producing artifacts, we're producing logs, kicks, logs, and we're storing all of this information. Everything that is going on is going to be stored, because if we're hitting problems in this testing phase and our testers start to fail, you don't want it to just be oh, that test failed. We want to know why. We need the material so we can dig through it and see what is going on. And then the last step, as I said, that immutability, using those managers, the managers understanding what they've pulled, what resources they provisioned / collected, it knows exactly how to clean up. So we're not leaving messy environments behind. So how does this all fit into a pipeline then? because that's kind of Galata's end of the stick sort of thing. But if we have developers like delivering change sets to our RTC, what happens then? So we can copy those change sets into a brand new RTC and perform a Delta build on them. We can rebuild kicks with that change set. Galata would then take in with some basic BVTs and make sure everything's looking like pretty good. And if we get past that, we can either promote that code or raise defects. So we have a little bit more confidence that the change sets that's just come in are actually at least doing what they say on the tin. But that's not ultimate confidence in one pipeline. This is a Delta build on a single change set, and we want a bit more than that. Because if we're going to push a change set straight to a PAX to give to a customer, we're going to need a bit more confidence in it. So the next step is we do a full build. About every 8 hours, collecting up all the change sets that have come in the last 8 hours and completing a core regression test suite across it. So we want to check that nothing has been introduced into the code with these change sets. We also do like an SMP install to make sure, again, nothing's broke. It is a working piece of code, but it gets one more step longer in this pipeline. The next step is a beta build. So this is where we can actually start generating artifacts that we could give out with confidence, because that's the point, isn't it, of all this automated testing and the hours of performance of work on the code that you put in your change sets, is so we can deliver something that we know isn't just going to break. So in the beta build, we do, again, another full build, but we run our entire test corpus against it. So everything that's been written to date that is relevant for that test, obviously that build, so if it's a different service release, will be run against it. And again, we do SMPE installs of both iStar and non-iStar to make sure everything is expected. And the great thing about this is, as it says at the bottom, bad changes never make it into another person's build. So this means we're not getting stuck behind that bad change set. Someone's not submitted a change set that doesn't work, and it's not holding up the pipeline. It's filtered by the pipeline and raises a defect back to that developer. So what's happening next in our world? Do you want to get...
So you've got different teams with different changes.
Yeah.
They're being done individually every 30 minutes?
Yeah, so it's copying it into a unique RTC workspace so they're not clashing with each other.
Okay. So they've got their own executable environment each?
So they don't have their own executable environment each that they can use. What's happening is we're building a version kit that's got, it's basically taken from integrated plus their change set. We've built that, and then
But it's like one change set from one source?
Yeah.
So there's not multiple sources coming
Not on the very left-hand side.
Okay.
So at the left-hand side of the pipeline, we are individually testing each individual change set on its own.
Yep.
When we get to integrated, we take a set of change sets that have been individually tested, group them together, integrate them, as it were, perform another build, and test that build.
And is that just like a complete environment rebuild within the integrator? It's not like another environment like a waterfall or something?
No, it's just spun up individual environment for that piece of testing.
That bit of integration.
And then as soon as it's done, it's ripped down.
Yeah. Thanks.
So what's coming next? We've talked about Galata, and I've already said that the Galata.dev is live. That slide is old because that should have said this week, unfortunately. But we should be pushing our current base of code out to an open Git repository this week. We're all quite excited about it. We've got our approvals finally through, so we're looking forward to it. I will note this is not a release. This is just us getting our code out in the open. We're hoping by late fourth quarter, though, we will actually have our 030 to be made available, which will have the full Eclipse plugin that will allow you to run Galata and debug Galata tests. The managers we hope to get out at that point are listed there. So we've got like the core and artifacts manager, 3270, ZOS, batch manager, HTTP manager, to allow for at least a basic level of testing that could be covered with it. Hoping for hitting version 1 through 2020. So, thank you very much. Is there any questions?
I'll leave until later because I've got to go to another I mean, it looks like a great framework. I think the approach in terms of the basics is very good. I do think you need to start looking at some APIs because it's very different dealing with something where you've done it in the labs. And while I used to work at IBM a while back, now knows it very well. It is a lab, and it is a very different environment between what you guys do in the labs and what you do in the custom lab. Very different way of doing shit. So they are looking for something. It ain't going to be plug and play. It's going to be plug and play. So they're looking for that, and most of them understand that. The coaches people who can't. But they are looking at ways of reducing the amount of coding they have to do to be able to get stuff in. Because they do look at it as an, quote, automated way of doing it. So you do need to think about getting that layer in there to de-stress these people when they start building this stuff. Otherwise, they're going to look at it and say, that's great, nice. It works really great, but it's going to have way too many resources to get them to run. There's too much coding, and the coding itself introduces risk because you can also get it wrong. Yeah? You always de-risk it all. So,
there's a couple of pieces here. I think the core thing is it's a framework, it's extensible. The whole point of open sourcing it is to build a great ecosystem around automated testing
Yes.
on mainframe.
that's fine,
So-
but you've got open source is not the be all end all, especially when you're into customers. Don't let this idea of it's open source. It's so liberty. It does not.
Well, there'll be contributions. I'm more concerned about the environments that you're provisioning, right? Because you have to identify where application boundaries are and how to build these and stand them up every 30 minutes or whatever the
No,
time.
so what we do internally is, we build up a Kix environment for every single test that we want to do. But we fully understand, as the gentleman clearly said, that what we do in the lab and what customers want to do are radically different. There's an awful lot of similarity, but there are some key differences. And one is that some customers may not want to start a new environment every time they want to spin a test. They may want to reuse the environment. And so we architect Galata to handle that requirement. So if a customer does, and we've been speaking to some customers who are planning on spinning different rounds for every single test that they want to run. And that's great, but then we've also got customers who say, no, I've got 5 test environments, and I expect your tool to be able to pick which one it's going to use and lock it to that test. And Galata can handle both. So, fully aware that, depending on where a customer is in terms of their DevOps adoption, will drastically change how they go about looking at test automation. And we've written an architecture class to try and accommodate both ends of that spectrum.
And I agree with that. My only comment is that I want you to be able to discover the environment and do it on. I don't have to provision it myself. You're running a test.
It's a bit
You
key.
touch.
Application discovery for us and many large customers is a bit of a key. The interesting thing to me is we've had lots of discussions around this. And if you're testing on the left-hand side of a waterfall environment in unit test land, I think a lot of these cloud things that we're discussing is quite relatively easy to do. Still you've got to do discovery, that's a big ticket. This stuff is all about final delivery to the customer right at the end. So it's much more of a right side of the waterfall diagram, the pre-production stuff, and you're still recreating the environments, redoing it, and you guys are working together really well. Ever since we've been talking about the DevOps story at Hursley, you can see that all throughout the life cycle you've got colleagues working together and invested in this delivery process. In our world, we're dealing with a lot of disparate teams, and we're kind of infrastructure people along the bottom. And getting these feature teams together, getting a cultural change, let alone the processes you've got to put on top before you can use the tool, I think that's quite a challenge. But they've shown it can work. And I was sitting there asking questions about skills, because I'm thinking, we've got to get all the people involved in testing together and get them to sort it out. because it's really easy, it's just probably just to sit around here and go, yeah, we need testing better. Yeah. But how are we going to do it? And it's a great example. So thank you very much, James.
One last thing though, as I've just been informed, today was right. It is now live. So if you can find us on GitHub today.
Great. Cool. Thank you very much.